In this lesson, we're going to talk about geometric probability, and we're also going to talk about finding the area or the perimeter of a figure on the coordinate plane. So first, let's talk about geometric probability. You have experience thinking about probability in a lot of different ways, like when you're playing a game or if you're watching the weather. The weatherman is going to say something like, there's a 70% chance of snow. In mathematics, we don't usually express those probabilities of something happening or how likely something is to happen in terms of percents. Instead, we use a number that's between 0 and 1. And 0 means it's not going to happen at all, and 1 means it's definitely going to happen. So that 70% chance of snow would translate to a 0.7 probability of snow. So you're just going to basically convert those percents by moving the decimal over twice to the left or dividing by 100%. So specifically, we're going to talk about geometric probability, and that's going to relate to figures or areas on a surface. So there's a few vocab words that we need to think about when we think about geometric probability. So one would be this word here, sample space. And so when we're thinking about sample space, what we're talking about is all of the possibilities that could happen. And then when we think about the word event, that would be like the thing that we're talking about, the probability of happening. So in the weather example, the sample space would be anything that could happen on a given day. Maybe it's sunny out, maybe it's partly cloudy out, maybe there's rain showers, maybe there's snow, maybe there's hail. And the event that we're talking about, in this case, 70% chance of snow, snow is the specific event. And then the probability is the division of the event, the probability of the event over all the things that can happen. So let's look at a couple of things here. So we're given a line segment, and we can talk about geometric probability in terms of length, and we can think about the sample space. So that would be all of the points on that entire segment. So every point from point A to point D in between. And then in this case, we're going to talk about an event, and the event is that I randomly select a point on that segment AD, and it happens to fall on BC. So part of the keywords there is that a random point is selected. So they all have an equal likelihood of being selected. And so the way that I calculate the probability is I find basically the number of points on segment BC, the event, divided by the number of points on DA. Of course, there's an infinite number of points on each of those segments. So we typically will just talk about the length of BC divided by the length of AD. We can also talk about probability in terms of an angle measurement and in terms of an angle. So let's look at angle. Here, the sample space is going to be all of the points on that circle. And then the event, usually with geometric probability, and when we're talking about area, usually they're talking about that shaded area. So what is the probability that the point lies in that shaded region cut out by that angle? And so what we're going to do is we're going to take the area of the event, which is that angle, divided by all the total angles, and we'll be able to find the probability of that point being selected in there. Now, to the right there, we have an example of area of that triangle. Our sample space is going to be all the points inside that rectangle shape. And then the event is all the points in the shaded triangle. And so if I want to know what's the probability that a randomly selected point that's somewhere inside that rectangle falls in the shaded region of the triangle, I'm going to take the area of the triangle and divide it by the area of the rectangle. You can kind of think about some other examples of probability, like say for instance, I was really bad at throwing darts at a dartboard. I could ask, what is the probability that I throw a dart randomly and it lands on the bullseye, given that it's going to land somewhere on that dartboard. So what you're going to do is you're going to find the area of the bullseye and divide it by the total area of the dartboard, and that's going to give you the probability that you're going to hit the dartboard. So let's look at some more examples on length. Example 1, a point is chosen randomly on segment PS. Find the probability of each event. So, when I'm doing probability, I usually want to think about what is the total there. So I'm going to look at PQ, QR, and RS and add those up. So length 7 plus length 13th and length 5, that's going to be a total length of 25. And then I'm going to proceed with these example questions. So on part A, they want to know what's the probability that the point is on RS. So I'm going to look at how long is RS. It's 5, and we're going to divide that by the total. Sometimes we express probabilities in terms of a decimal, but a lot of the time we're going to just leave that as a reduced fraction or simplified fraction. So I just want to put my fraction in simplified form before I write that as my final answer. In part B, the point is on PQ, so I'm going to switch colors here. The point is on PQ or QR. So basically they're saying if we're on PQ or we're on RQ, that would qualify as the event. Well, that has a total length of 7 plus 13, which is going to be 20. And so we're going to take it 20 out of 25 this time. So whenever we have an OR question, we typically will add those segments together. And then we'll go ahead and simplify the fraction. So there's a 4/5 chance that if we randomly select a point, it will be on PQ or QR. And then for the last one, they ask us a not question. So they said the point is not on QR. So there's a couple ways to think about it, but if you look up at the top here, if I'm thinking about whether an event's going to happen or it's not going to happen, to go back to the snow example, we said a 70% chance of snow or like a 0.7 chance of snow. That would mean there was a 30% chance of it not snowing or a 0.3 probability that it wasn't going to happen. So you can always do a not question by basically finding the probability of it happening and then subtracting it from 1. That's one way to do it. So I could say, okay, what's the chance of QR happening? Well, QR is 13 out of 25, and then I just need to subtract that from 1, and that will give me the probability of it not happening. Now, I've got some fractions here, so I'm going to convert the 1 to the same denominator, and then I'm going to do my subtraction here. So I've got 25 minus 13, that's going to give me 12 over 25. and that's not going to reduce. So that's the probability of the point not being on the segment QR. Of course, you could also do that a slightly different way. We could just add up all the stuff that's not QR. So that would be the 7 and the 5. So that would still give us 12 and take it out of the total. So it doesn't really matter which way you do it. Sometimes if you're dealing with a lot of numbers that you don't want to have to add up, it's a little bit quicker to just go ahead and find the probability of that event happening and subtracting it from 1.